Okay, so the last part in this chapter is related to the Big Bang Theory. Okay, so if we talk about some basics related to the Big Bang Theory, so around 14 billion, if we talk about the 14 billion years ago, the universe start expanding, right? And initially there was a very small region, and that small region was extremely hot and dense. Right? So initially, according to the Big Bang Theory, initially there was a before 14 billion years ago, there was a small region which is hot and dense, right? And then there will be a giant explosion. So after that small region, there was a giant explosion which turns into the Big Bang, right? So that is the basic concept of the Big Bang Theory, that how it happens. And this Big Bang will further allow the universe to expand. Expansion of universe. And finally, in yesterday's lecture, we discussed that a star will also work like the same. There will be a red giant star with giant explosion. Then it will convert into planetary nebula, white dwarf, black dwarf, or black hole, right?
All right, sir.
So in this expansion of universe, each point will expand. So each point is start expanding away from each other. And we already discussed about red shift and blue shift. So how it happens? So this will happen because of okay, so we already discussed about the concept of redshift. So we already have some concept related to the redshift, that particles or each body start moving away from each other because of the concept of that redshift wavelength, right? Because when bodies or planets start moving away from each other, so their wavelength will increase. And we also discuss it with the concept of the Doppler's effect. So that's why the universe start expanding, or each point starts expanding, and we also get the evidence with the reference of the redshift. And in the presence of redshift, or with the concept of redshift, we can easily explain that how universe will start expanding, right?
Alright then.
And further, if we talk about the evidences, because in your specimen paper, they also ask about specific evidence to prove that how we come to know that there was a Big Bang 400, 1400 years ago. So if we talk about the evidence, so the first evidence is, so if we talk about the first evidence, so first evidence is related to galactic redshift. So galactic redshift is the first evidence, and what is the galactic redshift? That is almost equal to the concept of redshift. We already talk about the concept of redshift. So if we talk about the first evidence, okay, so this is the very first evidence, which is related to the Big Bang theory or the expansion of the universe. And in this evidence, if we talk about the experimental concept, that how we can easily prove it. So let's suppose if we consider two concepts, let's suppose in first concept, this is the spectrum of light from closed object, and second will show you the spectrum of light from distant object. So according to the concept of redshift, what will be the difference between these two line spectrum? Now we have to draw the line spectrum according to their color distribution, right? So we know that when we talk about the red concept, so redshift means there will be greater spectral lines close to the red color, right? It means greater wavelength, less lines on the purple side or on the violet side. So it means there will be less light or less wavelength, because if we move towards the violet color, so wavelength will decrease, and if we move towards the red color, so it means wavelength will increase. So if light is coming from a close object, so spectrum will be like this, that most of the light, let's suppose if we consider red region, so this is the red region, then we are having the orange, and then we have yellow, then green, and finally if we consider the purple region over here, and same concept we consider for the second one, purple over here, red on the left, then orange, then yellow. This is the sequence of that rainbow color according to that. So we now have to divide the spectral lines on it, and the spectral lines are going to be like this over here. So this is the distribution of the spectral lines for the light source or the emission of light from a near object. And if we compare it with the spectrum of light coming from the distant object, so most of the spectral lines are shrink towards or come close towards the red spectrum because of redshift concept, right? So we observe most of the spectral lines towards the red color because of the concept of redshift, and only few spectral lines are on the other side like this, right?
Right, sir.
And in center, if we consider the green color also, so this is the concept of the spectral lines. And if we further talk about the theoretical comparison over here, so by diagram, you also got the concept that most of the spectral lines are closed over here. And further, if we talk about the first condition in which light source is coming from a closed object, so spectral lines are away from each other. So that's why red shift will provide evidence that the universe is expanding, right?
Yes.
And theoretically, we can write it as light waves are stretched by expansion of universe. So wavelength will increase so this is the concept of increase in wavelength, that why the wavelength will increase. And the second thing is this indicates so further if we talk about the remaining concept related to this evidence, so further we can write over here that if the galaxies are start moving away from the planet or moving away from each other, so their speed will also increase, right? As far as they start moving away from each other, so their speed will also increase. So one more point is the further away a galaxy the faster it is moving away from the Earth. So it means greater the distance, greater will be the speed of that galaxy moving away from the Earth, right? So this is another evidence from this galactic redshift for the Big Bang theory. So according to all the concept and all the theories we studied over here in galactic redshift, we easily identify that how Big Bang start, and that will also provide the evidence for the Big Bang theory, right?
Right, sir.
So we got evidence how galaxies are moving away from each other or away from the Earth, and with greater speed they are moving. And there is a concept of redshift because wavelength is going to be increased. The concept which we already discussed in the Doppler effect. So that is the first evidence, right? And if we talk about the second evidence, so the second evidence is known as the cosmic microwave ground radiation. So this is the second evidence, or in short form, they ask with the reference of CMBR, cosmic microwave background radiation. So this is the second evidence, and this is the second evidence for Big Bang in the concept that when scientists observed the whole phenomena and studied all the concepts, so they find the radiation in the range of microwave. You remember we studied in electromagnetic spectrum that when we are moving towards right hand side from the red color, so after red or after the visible region, we are having infrared, then we are having microwave, right?
Yes.
So CMB is a type of radiation. It is a type of electromagnetic radiation which is a remnant from the early stage of the universe. So with the concept of this early stages of the universe, scientists concluded that the initial wavelength that was emit out from the explosion or after that Big Bang theory, they observed the wavelength, and the wavelength is around, the range of that wavelength is around 1 millimeter, and that is the range of microwave. So that's why we consider this one as cosmic microwave background radiations, right?
Yes, sir.
So the wavelength which was observed was equal to the wavelength of that microwave. Now we studied in electromagnetic spectrum. So that's why we consider this whole concept with the reference of cosmic microwave background radiation, because in initial stages of that explosion, scientists observed and get radiations in the form of microwave. So that's why we consider this it as CMBR. So normally in 1964, when astronomers discovered this radiation, so all spectrum is going to be emitted in all direction, and there was a uniform temperature of around 2.73 Kelvin. So the whole process we discussed with the reference of the life cycle of a star. So same thing like goes with the universe in the Big Bang. So further, if we talk about the concept of the CMBR, so let's suppose if we consider a graphical representation of this wavelength, so if we start moving towards microwave, right? Let's suppose if we start from the left hand side. So initially, we are having a concept of, let's suppose if we consider the initial time, and the initial value of time is 300,000 years after Big Bang. So after different or after so much time here away from the Big Bang theory, and the temperature was 3000 Kelvin. So at that time, if we want to draw the radiation or if we want to draw the wavelength, so how the wavelength of the waves was at that time after 300,000 year of Big Bang theory. So that is the time before the Big Bang theory or very close to the Big Bang, because we studied that we start expanding the universe after 14 billion year of the Big Bang, or we can say that now the current time or the current generation in which we are living is about 14 billion year after Big Bang theory. So what was the radiation or what was the wavelength of the radiation at that time after 300,000 year of Big Bang, and what is the wavelength now if we talk about in current generation and in current time after 14 billion years of Big Bang theory. So we discussed that galaxies are moving away from each other, so wavelength is increasing. So initially their wavelength was increasing or decreasing as compared to the current time.
Increasing.
Nowadays it is increasing, and if we go backward in the time, so initially wavelength are very short, and with the passage of time wavelength will start increasing like this, right? So this will give you a clear idea of wavelength, that how wavelength are going to be increased with the passage of time. And the final stage is the present situation, where wavelength is very much high as compared to the initial stage, right?
Yes.
This is because initially universe is not expanded as much as nowadays, because it takes time to expand. So after 14 billion years, that was a huge time. So you imagine that how much universe is expand till now. So that's why initially universe was expanding, but not such expanded if we compare it with the current time. So that's why the wavelength are very short as compared to the time period in which we are living now, right?
Yes.
So that is the second concept or the second evidence which is related to the Big Bang theory, right? And further, if we write some concept related to it, so initially the radiation would have been high energy, further the same concept we already discussed, as the universe expands, So the wavelength will increase, right? And with the passage of time, with the passage of time, the wavelength will increase. And reach the region of microwave, right? Any confusion?
No, sir, all clear.
Okay. So this is the concept of the evidence of the Big Bang theory, that how Big Bang happens and which what are the evidence that suppose the Big Bang theory. So in this chapter we studied about the redshift, the blue shift, the life cycle of a star, and the Big Bang theory plus the evidence for the Big Bang, right?
Yes.